Okay, in this lesson we will see on how to use mesh and nodal analysis to solve the circuit. So for the first case, we use the same circuit from the previous lesson, and here we also will use the same circuit for both nodal and mesh analysis. So here we will start with mesh analysis first. So for the mesh, we will create equation for each available loop. So for example, here we have two loops. I can call it this loop as follow this current. So this is actually I1, and this loop current is actually I3. Okay, so we have two loops here, and we will apply Kirchhoff voltage law for each of the loop. And for the sake of simplicity, just mark the plus minus for the resistor here already available for VR2, and for this direction this will become plus and this will become negative, and this will be helpful to create the Kirchhoff voltage law equation. So for the first loop 1, we have 9 volt. So we will take the ending polarity when we go through this, what to call this loop, 9 volt. Here my ending polarity is actually negative, so negative 2k I1, and here we have follow this polarity negative 3k. Here have to be careful because we in this line we have two currents effectively. So when we go through in this direction, same with this I1 direction, so this current is actually effective current on this line will be I1 minus I3. This I2 equals to I1 minus I3 equals to 0. Okay, equals to 0. So finish the loop done, Kirchhoff voltage law done. So then rearranging this equation, we will have minus 5k I1 plus 3k 2 equals to 0. Okay, this is first equation. And for loop 2, for this loop, we can start with here this resistor first. So for to put plus minus negative 2k I3 negative, ending this side 3k. So here we have effective current on this direction I3 minus I1. Rearranging this equation, we can have three k I1 minus 5k I2 equals to 0. I3 equals to 0. So by solving this equation using simultaneous equation analysis of matrix, we can have I1 equals to 2.825 milliampere and I3 as 1.6875 milliampere. Okay. So finally we can get this one more current here, I2 would be I1 minus I3 So there we will have 1.125 milliampere. And if you want to obtain the voltage across this resistance, this answer should get similar with the previous analysis. So VR2 we will have equals to I2 R2. So this current multiplied with resistance, we will have 3.375 volt. Okay, so this analysis is complete. We use the same circuit, similar circuit to analysis using nodal analysis. So for this circuit, if we observe, we only have one node. Okay, and let's name this node as X, for example, and we just use the given current direction I1, I2, I3. Otherwise, we can put the direction of current as what we like, but since the current direction already given, just follow the direction. So here at the node, we will apply Kirchhoff current law. So I1 equals to I2 plus I3, and I1, this current is actually V1 minus Vx over the resistance here, and since V1 already given, we just use 9 minus Vx over 2k equals to I2 equals to Vx over 3k, and this I3 equals to Vx over 2k. Okay, then we will simplify. We can remove this k, eliminate this k, and we can simplify this equation multiplying by 6 minus 3Vx equals to 2Vx plus 3Vx. Okay, then the total Vx, in the Vx we will have 3 plus 2, 5 plus 3, 8 Vx equals to 27. The Vx should be equal same with VR2. If we didn't get, then we might have made some mistake here. So Vx get 3.375. Okay, why Vx same with VR2? Because we don't have any other voltage supply here, so Vx will be same with VR2. Okay, so then the current, for example, if we want to get the I1, we just can use the same equation. I1 equals to 9 minus Vx over 2, and here this current we can get by Vx divided by 3, you'll get the same current. So everything will be same with the circuit. Okay, so I'll just give one example. For example, let's see for I2 equals to Vx over 3 kilo ohm, so 3k. So here we have 1.125 milliampere, which is same with I2 obtained.